Hi everyone, my name is Mahmoud Sheikh and welcome back to Unix shell programming tutorial series. In today's video, we are going to discuss about writing a shell program to convert a decimal number into binary equivalent. So before coming to today's topic, I just want to tell you guys that if you guys like this video, click on like button, share it with your friends. Don't forget to subscribe to this channel, and if you guys have any questions, then let me know in the comment section. Now let us start our discussion. As you can see, I have already written down the output of this program, and when this program gets executed, it will ask user to enter any decimal number. Let us suppose user has entered 15, then your program needs to convert that decimal number into binary equivalent and you will get the answer as 1111. Okay, so to get this binary equivalent, we have to perform 4 steps. Okay, now let us see those 4 steps. Let me first do this here, 15. Okay, now to get the binary equivalent, we used to perform this task 2 7 14, and then we'll get 1 as a reminder, 2 3s are 6, and we'll get 1 as a reminder, then 2 1s are 1, and we'll get 1 as a reminder, and we'll count like this, and we'll get 1 1 1 1. Okay, now let us consider this as place 1, this as place 10, this as place 100, and this as 1000. Here we need to create few variables. So since I am asking the user to enter a number, let us say 15, now in our program we need to create one variable which will hold that value. So I will create a variable with a name as num. Okay, so what should be our approach? First we need to find the remainder of this number 15. So to get the remainder, we need to perform the modulus operation on this number with 2. Okay, 2 7s 14, and we will get 1 as the reminder. Okay, that step we need to write in the form of program. So here I want to find the reminder, so I need to create a variable with the name reminder, and this is our num value, num mod 2. Okay, we'll get 1 as a reminder, and that 1 will get stored inside reminder variable. Next, I am finding this first bit of this binary number. Okay, as you know that the place of this 1 is 1. Okay, so I need to create one more variable with a name place, and I need to initialize 1 at the very beginning. Next, since I am calculating binary number, so we need to create one more variable with a name binary, and I need to initialize it as 0. Okay, so this is the variable inside which we are going to store the binary equivalent of 15. So now next we need to store binary value equal, let us say equal binary plus, okay, we have got the reminder in last step, and that reminder value is 1. Reminder into place. Okay, so these are place value. So we have got 1 as the reminder, and we are multiplying that 1 with the place value, which is 1. Okay, as you can see, place value is 1, and we will get 1 into 1 1 plus binary 0, so we will get 1 get stored inside binary. Okay, so we got the first bit of this binary number, which is 1. Okay, now next we need to divide this number 15 by 2. Num by 2. Okay, when I divide num by 2, I will get 7. Now the num value gets changed to 7. Next, I need to multiply the place value with 10, because I want to find this second bit of this binary number, and the position of the second bit is 10. So place is equals to place into 10. Okay, place value is 1. Now 1 into 10, which gets changed to 10. Now place becomes 10. So how long we need to perform these steps? Until the value of num becomes greater than 0. Okay, until the value of num becomes greater than 0, we need to perform these 4 tasks. Okay, so let us quickly try to see each and every step. Okay, initially the num value will be 15. Okay, 15 is greater than 0, condition becomes true, control will come inside this while loop. Then reminder num mod 2, num is 15, and when I perform modulus operation on this number with 2, and I will get 1 as the reminder. So now reminder becomes 1, then this instruction gets executed, binary value is 0, 0 plus reminder is 1, 1 into, okay, so reminder is 1, okay, and then binary is 0, place is 1, okay, reminder is 1, 1 into place 1, 1 into 1, 1 plus 0, so we will get binary as 1, okay, we will get binary as 1. Next, num by 2, okay, when I divide 15 by 2, I will get 7, okay, now num becomes 7, then, okay, num was 15 and now it becomes 7. Place into 10, place value is 1, 1 into 10, now place becomes 10. Okay, next, control again goes back to while. Now num is 7, so here we will get 7, we will get 7, okay, 7 is greater than 0. When we perform modulus operation on this num whose value is 7, so we will get 1 as a reminder. As you can see, we have got 1 as a reminder, so 1 gets stored inside this. Next, this reminder is 1, 1 into place is 10, 1 into 10, 10 plus binary was 1, so 10 plus 1 we will get 11, so binary will become 11. Next, num is 7, 7 by 2 we will get 3, okay, now num becomes 3. Next, place equals to place into 10, place is how much, place was 10, now 10 into 10 and we will got 100, now place becomes 100, okay, now we are finding this third bit whose place is 100, okay. Next, now num is 3, again control goes back to while, so now this is 3, 3 is greater than 0, yes, now 3 comes here, 3 mod 2, we will get 1 as the reminder. Now reminder is 1, 1 into place is 100, 100, we will get 100 plus binary is 11, okay, we have got 1, 1, 1 now, okay, now binary will become 1, 1, 1. Next, num is 3, 3 by 2 and we will get 1, so 1 gets stored inside num, now num becomes 1. Next, place is 100, 100 into 10, 1000, now place becomes 1000. Next, num value is 1 now, so again control goes back to while where the num value becomes 1, okay, 1 is greater than 0, condition becomes true, control comes inside the while loop to perform this task. Now this is 1, okay, 1 mod 2 and we will get 1 as the reminder, so reminder is 1 now, 1 into place is 1000, okay, 1000, 1000 plus binary is 111, so we will get 1111. Now next, num, okay, num is 1, 1 by 2 we will get 0.5, so num now becomes 0.5. Place is 1000, 1000 into 10 we will got 10,000, okay. Next, control goes back to while, here now num becomes 0.5, okay, so now we will consider only 0, okay, so now you can see I will discard 0.5, so 0 greater than 0, now this condition becomes false, so that's why control will not come inside the while, control will come outside the while to print the value of binary, okay. So this logic we will be applying to write the shell program. So we'll start the program with the shebang statement, bash, then I will read the number which is decimal, num, okay. Next, I will initialize these two variables, okay. Next, I will start the while loop. While space 2 square open brackets, then while dollar num, okay, is greater than 0, do reminder is equals to mod 2, then I need to find out the binary. Binary is equals to dollar binary plus reminder into place. Num is equals to dollar num by 2. Next, place is equals to into 10. Done. Next, we will print this binary number, echo. Okay, so this is everything about writing a shell program to convert a decimal number into binary equivalent. I hope you guys have understood this concept and how this program works. So that's all for this video, guys. I hope you guys like this video. If you guys like this video, or if you got some useful and valuable information from this video, then click on like button, share it with your friends. Don't forget to subscribe to this channel, and if you guys have any questions, then let me know in the comment section. Thanks for watching.